it's trying to combine two programs, astrophysics with known biology. And it's not easy to do because biology's been they've been researching biology since the 1500s, so there's a lot of data they've collected over years. And you can go back to any book, like I've got a book called Invertebrate Zoology, and you go to the reference guide and you got science journals dating back to 1850, 1840, even the turn of the century. And so it's taken a long time to get all that data. Yeah, I've been knocking Darwin's theory of evolution, and because they threw biology off, but they also were a lot of people that had to live on low income to do all that. So they didn't really have a government that financed research, and so that's one of the reasons they've never developed that wing of government where you could actually do they will do serious investigational research. So I mean, it's a product of over going back to even the 1500s with kings and queens, and even going back to the discovery of America to Queen Isabella, actually a woman queen that sent Christopher Columbus over here. Spain wasn't the first kingdom Columbus went to. He went to several kingdoms, and she's the only one willing to use her navy to do that. And I ran into the same problem. Remember, there's also a volunteer fleet, and I ran into the same problem in submarines. There's a lot of, I wanted to, since we're cruising around out there, use bring a science team or a biology team, marine biology team on there, and with some cameras and stuff, and put some floodlights down there. And if we picked up any kind of new species of fish or anything, since we're cruising around there anyway, hey, we would catch it on tape, and it would add on to our data. But I'm a minority out there, and the officers out there an officer out there that did support that is also minority. So we're not running the U.S. Navy. There was a Hollywood movie series that was put out called Seaquest. It was on for 2 years, and I guess they go by the Nelson ratings, and support for it kind of went out. So that's kind of what I had in mind for the U.S. Submarine Service. But if I had been an officer in the Navy, I would have never made it to lieutenant. And Seaquest, was more my ideal of the submarine service. It would be more 80%. There's no war going on, and it'd be more of a preserving the ocean and using the ability to do biology and research and stuff, marine biology, and do research out there. Besides having the ability to go to war, which is what Seaquest was. So that's not the Navy out there today. It'd probably take a global government to get that Navy out there, and I can take any 688 attack submarine and use. There's no socket you can connect in to connect cameras up out there. You'd have to do it by battery, but you can use strap on the underneath of the submarine, and if they had to go into war, they could just go to the surface, blow off the cameras and the floodlights, and then they're ready to go to war. I mean, it's not like you couldn't use a submarine for that purpose, but I mean, that's, to me, just cruising around out there isn't my ideal of a submarine service. I was looking more into Seaquest. So, but anyways, that's not what the Navy's been for the last 200 years. They're strictly for war, and it still is. But as the saw what happened in the Falklands War. They finally fought a high-tech war, and they lost several. The UK lost several ships. The Argentine Navy lost the Belgrano, and they lost a crew of 300 men. They didn't get to jump overboard; they got smoked. And that's what problem with high-tech warfare is it's one shot, one kill. There's no jump overboard and go get in the rescue ship. If a torpedo hits a submarine, it's over with. There's no. That's one problem with high-tech warfare, and they did finally fight a high-tech naval battle. The Argentines didn't have what UK had, so they lost the war. So, but that's one of the problems with why that Navy needs to evolve into something like Seaquest, where it's not all military missions, and it'd probably take a drafted crew, and that's not, they haven't put a draft out in over a decade, but you'd have to be hand-picked, and you'd have a hard time, even if I was the one picking the crew out for that Navy, I'd have a hard time finding people to use a submarine for that. I mean, it's just, it takes a new type of government, and it would take a new international government and a new Navy. So, Seaquest is still science fiction, but anyways, okay, this lecture is going to be more on what our origins are and comparison with invertebrates. To do that, you have to study embryology, and because we're a product, starting out as a single-cell organism. We're no different from anything else. In fact, all the organisms start out as single-cell organisms. So it's chickens, it's a mouse, or whatever, even a dinosaur. Start that as a single-cell organism. So what the difference is the nucleus. And once the nucleus is there, now we have the possibility of advanced organisms. But for the first billion years of history, saying that carbon dating is correct, and I have doubts as to how accurate that is. I'm looking at when Neil Armstrong sets down on the moon, how far his foot goes in. It only goes in about this far, so we know the moon isn't that old. It's not 4 billion years old. It's been recent, but on the Earth we have atmosphere. So the carbon dating, I have questions about now, but that's all they got. So you have to go with what they till we find a better way of dating. That's all they have right now. But anyway, so all organisms start out single-cell organisms. The difference is the nucleus, and that shows up maybe shows up a billion years later. And I've said in my past lecture, there's a gap between advanced organisms and the early organisms, which are basically plankton out there in the ocean water. And I've discussed that as far as aliens go, the possibility that aliens were out there, 4 billion years ago, and they were setting up the basic biosphere of the planet. So. And then there's a billion-year period where there's just simple life forms, and then the nucleus arrives, and now more advanced life forms come into being. But there's something that, just like that, it's not something that evolved. They can't show that in archaeology. There's no evolution link between those two worlds. There's only speculation as to what created those, and all they had out there was Charles Darwin for a long time. And, I'm not knocking their data. They did a lot of data research, but there needs to be a government-funded programs to do investigational research, and it can't be through the private field. There's a lot more. It shouldn't take us 400 years to get where we are today, But the problem was a lack of government financing. All right. So anyway, single-cell organisms, and we know the nucleus arrives, And so that's what basically what we are. And what creates the change in our nucleus or single cell organisms is a flagellum. And it doesn't have any intelligence, it just has a tail and a nuclear head. And within the head is 3 enzymes that create the fusion. And anybody that's taken biology in high school knows that the fusion creates the reaction within the single cell organism that actually morphs into a second split into 2 distinct nucleuses, and they say they're both female and male, but they don't. In their biology books, they don't. What are they offering as proof, other than just they're just 2 nucleuses. But there's 2 after that morphosis. There's 2 nucleuses, and then the chromosomes reduced, and you get another morphosis, and you get into now a reaction, kind of a reaction that goes on, and a whole bunch of chromosomes, molecules come together, and we start evolving into basically a flatworm, just basically a head, a brain unit, and a body unit which combines. So what's interesting about that is I'm going to tell you something new, is that energy is also part of that. I was watching there's a medical doctor over at on YouTube. It was I can't think of the name of the site, but he was doing a lecture and his investigation of that too, and what voltage and energy is part of that. But it's also part of the fusion process, because in the early stages of human life, there's a tree that arrives, and let me get to it. And from that, the fluke arrives. I mean, basically, a fluke arrives, and you get the brain unit, and you got what becomes eventually the body structure. But it's basically a tree. It's just like lightning. And if you look at the pattern of lightnings, it forms a tree. And so that fusion, it's a form of energy that arrives within that nucleus that branches out, and it creates that life. So energy is part of it. What they don't know is what is that energy. There needs to be more investigation into black body radiation. There is an aura. They don't have an explanation as to what that is. Or some other explanation is chemical reactions. That was what the medical doctor's explanation for that is. That's a possibility, but there is energy involved in that. In that energy, and it's also part of that design. I would suggest more that is part of the design. There's energy within that nucleus. It goes up, branches out, and starts creating the fusion that's part of the cells creating. It's not something we discovered recently, that the total DNA, RNA code, lines of code that create us, goes from New York City all the way out to London. That's a lot of information, and to be able to put all that information into a human being I just don't think that that little single cell organism has the ability that has to come from somewhere else. And I'm going to suggest that in this lecture, that comes from, there is a heaven, that does come from somewhere else. I just don't think our reproductive system is capable of those advanced genetics it's very, very dynamic, and to go from a single cell organism and the eukaryotes to more advanced organisms. It takes some form of programming, and we already know that the aura is part of the human body. You've seen it in Korean photography and stuff, and I call it an Area 51 you can't get to. You can read life after death studies if you want to. Only about 22% of people have ever had one, and it's well documented on operating tables in hospitals with medical doctors, but only about 22% of people have ever had a experience where they were floating around their body and stuff. So what does that tell us about that stage? Even with kids, what do kids know? Most of us don't have any memory. I remember my memory at that point is about 5 years old. But before that, I have a very vague memory. So even when we come into consciousness, our brain is still developing, but it's not at an advanced level yet where we're actually, we don't have the ability to read yet at 4 years old, or 3 years old, or 2 years old. Our eyes are still progressing. But I'll tell you about that they've done research on embryos as to whether it's conscious or not. But they find out it's a semi-conscious level, and it's not full consciousness. Basically, that's the reason why that is to protect the mother. You don't want the embryo to break out of the sac, and you want it to reach its final stages. So it's basically to protect the mother, which is should be a study to find out what's being secreted by the mother that keeps the embryo sedated in that subconscious state, especially when it comes to advanced travel. I mean, in space, when it comes to, if you're going somewhere that's 4 light years away and you got to be asleep for 4 years, what is keeping the human body, in that's a very semi-subconscious state, because we mostly don't have much memory of that. But there is some form of memory about that state. And there's a movie called Indigo, and it's about a little girl that has psychic gifts and stuff. And her stepfather or father comes in, and he asks her why she's drawing all these pictures on the walls and stuff. And kids are just natural artists. And even at 5 years old, kids are drawing and stuff. So we know that that's a carryover from that subconscious state. It's a point of creation. That heaven is a point of creation where there's creation is going on and stuff. And it's part of the kid's subconscious. She says that the pictures and stuff are talking to her. And so, the kids are just natural artists. I mean, that's one kids start walking and crawling and stuff. They get crayons, they start drawing all over the walls and stuff. Even when we were in caves, we were still doing art of some form or another up on the cave walls, even when we didn't have the ability to communicate with each other. So, even though it's a subconscious level that's not totally conscious, kids do have a memory of that in their subconscious, and it's a point of creation. So from a quantum physics perspective, I would say that is one proof that there's more to that world than meets the eye, So don't think that there's more to the story than what we're looking at in biology. I just don't think the human reproductive system has the ability to produce advanced forms of life without some help from an Area 51 that we can't get to, which if you want to call it heaven, okay, we'll call it heaven. We do know that it's not a place that we can go, it's its origins of it. I'll give you a good example that after about 4 weeks, the heart starts beating. And so once life begins and the heart starts beating, the body fluid's going down, the zygote's in a subconscious state during that time period. So now we're going from unconscious to subconscious, and there's like a door that closes. It's been in some of the art and stuff that if you want, there's information going in at the at the no conscious level, and then after 4 weeks or 5 weeks, the heart starts beating and developing, and now there seems like there's a door going shut, and then there's another program that arrives, and we start getting into the more advanced life form, which is at 8 years old, we're basically fully developed, other than we're growing, and the brain is still growing too. But basically, as far as how we look and stuff, all that is been pre-programmed and stuff right up to about 8 years old. So, so there's more to the story than Biology 101 has to discovered. I'm going to read you into some of their explanations, some of their states. The morphogenesis. Morphogenesis is the development of the human body form. That's part of the state during that time period. I'll tell you what's going to be eventually going to be coming up soon. To back up some of my arguments, is they're going to be able to develop a spectrometer. And as I've said, some of my predictions have come true, but I see a spectrometer being developed where they can take the DNA code and start running it and see what's going on from the point of fertilization right on up till, I guess, 25 years old, and the DNA they'll be able to watch through a spectrometer, and even after you're born, they can monitor what's going on up to about 25 years old, and they can watch the DNA code. So we have a total human genome, and we'll also be able to see what's going on during that time period. They'll be running the DNA code and watch what's going on. It's a very complex process, but once they have that spectrometer, all they'll be doing is sitting there at a computer and probably bored shitless, but they'll be sitting at a computer and they'll be watching DNA code, going on and on and on. And they can do that on all the animals out there. They're already doing that with the simple single cell organisms, the plankton, because they're having a crisis in their ocean right now. So it's basically, they're going to have that editing basic creating plankton and stuff, single cell organisms and stuff, is now critical to keep life going in our ocean, because they do have a crisis out there. So they've already got the ability to do some of that, but they don't have the full story. But anyways, we're not a whole lot different than fluke. Tube worms. I would suggest that the creators of us were also the creators of the fluke worms at that time. And you look at the features of a tube worm, it's a lot similar to us. You can look at the diagrams and stuff. It's digestion of food. Many tubularia contain zoocolectra, and some are said to subsist entirely by digesting their symbiotic partners. Well, we do that too. We eat other organisms. Necessarily, but feeding is a major problem in most tubularia. A few take in some plant material, but the majority are strict carnivores. Well, that's what we are. Most of us aren't, we're vegetarians, so that gives us clues. It's one of the reasons why they started investigating tube worms back a long time ago, because they started seeing comparisons between tube worms and their studies in embryology, and they noticed saw a link. Dard just told them there's a natural selection link and mutations that evolved into that, which isn't true, but they started seeing a link between us and earlier life forms. But that's what threw biology off, is Charles Darwin. So nothing I can do about it. They did do a lot of investigative research over all those years, and they did discover lot of good stuff in biology. It took a long time to get to this point, but it should have been a less time if we'd had a better government. But anyways, efficient chemoreceptors are sensitive to meat juices, and receptors enable them to detect nearby prey by water disturbances. So they already got a good sense of hearing, and they also got a good sense of taste, so, which is what we have too. So in a lot of ways, they're no different from us. So let's go to the next section. We go to respiration. Tubular and injury releases appears to be predominantly aerobic and with a few peculiarities. It's largely cyanide sensitive. This indicates a Warburg-Kalin system involved in which after dehydration, hydrogen is transferred by cytochrome oxide system to the final hydrogen acceptor oxygen. A small cyanide-resistant fraction is probably maintained by iron-free oxidase. So no special organs for respiratory exchange or transport occur. The epidermal ventilate the body surface and undoubtedly improve the rate of absorption. And hemoglobin has reported from a few rhabdicoles, but is not widely distributed. Available evidence in the whole supports the idea that the lack of a more effective system of respiratory exchange and transport, the respiratory requirements of internal cells are a critical limiting factor favoring small size and flat shape. That's why they never evolved. They aren't us. It takes a better respiration system. But our respiration system goes in two stages. First, we're breathing liquid, and when we're in the embryo stage, and once we were born, the medical doctor turns us upside down, and all those fluids come out of our lungs, and then he spanks us on the butt, and we cry for the first time and breathe. So we're no different from fish, and I've suggested that maybe that is possibly of an alien, because that we have an alien origin, or it's another life. Another alien type that's similar to us, but they spend part of their life in the ocean, which is an astrobiology question. I can't prove that because I can't prove that mermaids exist. There is a clip on YouTube where an underwater submarine out there, it was a news crew. There had been reports of seeing them out there. I was in Submarines. We ran across that stuff too, but we don't have any pictures. And there's only recordings of strange noises and stuff. So I don't have any proof other than that YouTube clip, and it was a news crew that was down there. And what happened is they were down there with underwater lights, and one of them came up to the glass and put its hand up on the glass. And I've used that on several of my lectures. It's basically a webbed hand. But it's very similar to our hand, other than the fact that there's webs around its fingers, which would indicate to me, proof that mermaids do exist. But as of right now, since all submarine information is still classified, that's the only thing we have. All the recordings and stuff that navies do get out there and stuff, it's still classified and never make it off the submarine. So, that's one of the problems we're proving that mermaids do exist. You have to have good evidence, and the only thing we have is that camera picture of one putting its hand up there against the glass. So, but it is an astrobiology question, forecasting as to what possible life forms are out there, which makes biology interesting. The only reason why I'm even studying biology, because I have the ability to forecast to figure out what might possibly be out there. It's something my father taught me when I was a kid and younger and stuff, is the ability to analyze data and forecast on it. My father did work for the Central Intelligence Agency, and that's what a PhD in economics can do. But that's not my interest. But either way, my interest is more science. But it's a tool that you can use to forecast into biology and stuff as to what the possibilities are out there. So we get back into flagellum, locomotion and movement. Tubal area, a millimeter or so long, flash across the microscopic field. Large ciliates leaving an entirely different impression than large worms like Digasia. Mussels contribute little to the movement of small species, moving a little large animal with the cilia's rather than rowing an ocean line. Wriggling movements become more important in such large forms as the land planarians look superficially like earthworms as they move. It's more of a reactionary type movement. It's no different from jellyfish. It's more of a reactionary. If you touch it, it's going to move. If it feels water flowing across and stuff, the ocean waves and stuff, it's going to react to the movements of the currents and stuff. But it's not really true intelligence. It's just a reactionary movement, and it's that part of our early brain. What is a medical doctor? Somebody has an accident, so or he's checking for something. What's it do? Takes his mallet and he hits you in the knee, waist, and looking for a reaction. Well, it's the same thing. That's what a medical doctor is checking. It's an early form of intelligence that's not really true intelligence, but a medical doctor that's one of the ways a medical doctor detects to see if that was hurt during the accident. So, the nervous system. Evolutionary tends, this is 1969 book, but it's a good biology book. But there's evolution throughout it, so you have to reinterpret data and stuff and go through that stuff because it's full of evolution. Evolution it's still mainstream because they still have all the books out there were done from an evolutionary perspective, and it's even in this book. But evolutionary tends to first see flatworms establish a general pattern retained in the nervous system of the higher invertebrates on the annelid arthropod stems. Factors associated with the development of the nerve system are cephalization, abundant and more highly specialized sensory organs, a more complex muscle system, and demands associated with higher inhibition in the highly active moving animals. And so, the nervous system of a flatworm is geared toward movement. You have to be able to have autonomous movement so that you can actually swim. We can swim, and I'll give you a good example, but that intelligence is also part of the Komodo dragon. While these are big lizards, they have seen, the Japanese researchers have seen Godzilla can swim. And there's no explanation as to why he never left the island. Probably because he's just having a good time out there and didn't see any reason to. But that Komodo does have the ability to swim. So we know lizards can swim. It's the same reaction. So it's part of the nervous. It's one of the advanced life forms have a good central nervous system to be able to do those competitive motions. So the evolutionists can't figure that out as to why there's no Komodos all over the world when there's just one island that has them, because they were put out there. And how they got after, I can't prove it, but there are UFOs flying around out there and stuff. And I've said that they're drones, but there's a possibility that that's how they came and got out there. It's not something we can. It's a distinct possibility. So let's see. But that's pretty much it on this, as far as this lecture goes, on our origins of some of the biological discovery that they've had the last 500 years. So what they don't have is the full story yet, but as the time goes on, I said it's a spectrometer eventually arrive where they can actually read DNA code. That's not out there yet, but I can see that happening eventually. So the full story isn't out there yet. So that ends this lecture.